Now, I hope people can see this board clearly. And we start with why and so what. The reason is, if you understand this, the rest of the problem becomes simple to analyze. Let's say you have a problem of malaria. I will give this example and you will be also following it at some point of time, not today itself. But when you are there is a group of 4 or 5 people, you should try to do this exercise. Why and so what? Now, when there's a disease known as, let's say, malaria, you ask a question why. Then there will be certain answers to that. One thing would be parasite entering the body. Second thing would be low immunity. Third thing will be host exposed to mosquitoes. Now, why low immunity? And again ask the question why. Then if you go for why immunity is less, then there will be 3, 4 other reasons. For example, poor diet, then stress, then there could be antibiotics, then there could be a aging process. So many things could be there. While you talk about why parasite entering in the body, there could be a mosquito breeding, then infected mosquito, and so on. Now, this is the first time you have asked why, second time why, then there is third time why. Why mosquito breeding? Why there should be infective mosquito? Why there should be poor diet? Why there should be stress? If you ask this question 5 times, then at the top you will get so many other things. But then some basic factors will be the same. Poverty, illiteracy, lack of education, lack of health awareness, etc., etc. Now, the question is why the epidemiologist is interested on these factors? Because we want to prevent the disease. In that case, there are so many factors, and if you go on and on, it is known as web of causation. This is very essential to prepare web of causation. And if you prepare web of causation for 3, 4 disease or 10 disease or 15 disease, then you analyze all the diseases, then you will be finding out what are the common factors which is affecting of so many diseases. And based on that, you are going to prepare a matrix. And the matrix will look something like this. Here there will be a disease like malaria, TB, or diabetes, hypertension, like this. And here there will be factors. For example, waterlogging, or stress, or diet problems, something like this. Or maybe addiction. And then in this, initially we will just put like 012, 012. For example, waterlogging, not related with diabetes directly, then you may write 0. With a malaria, let's say 5, something like this. And at the end, on both the sides, row total and column total, you will be able to have some kind of score. This is arbitrary right now, but based on statistics, at the end, you will be able to give a weightage. That which one is more important, give more weightage. And then this why and then so what. Based on this, you are going to do the planning. So here, before I go for the so what, let me make it clear that everybody have understood this why questioning 5 times to get a web of causation. And your assignment to all the 62 people will be, you take up any disease, whatever you like, and if you cannot ask 5 times, you don't have that much time, at least ask 3 times, why malaria? Why these points? Why these points? And if you do this much, then next thing is, so what? If there's a malaria, so what? What will happen because of that? Then people will go for the treatment. Then people will loss of wages. Then loss of study days, sufferings, etc. If there is a loss of wage, what is the problem? There could be a poverty in certain cases. Because of low and study, there could be a poor result. Then, so first when you ask us, so what? This treatment, if you have 1,000 cases in a 2,000 population, burden will increase. So increase burden on society. Now another question, so what? If there is a poor result, what will happen? Low education. Again, low job opportunity. Why poverty? Then poor purchasing power. Again, then may lead to malnutrition, that is undernutrition, and burden on society. You require more medicines, more doctors, etc. Again, ask, so what? So what will happen here? You should note down that sometimes the thing which is causing the disease itself may lead to a causes which cause a disease. So a cycle can run like this. Poor nutrition, good. So this complexity, if you go for why and so what, for 4, 5 or 10 diseases and sit together, then probably you will come to know where you should be striking. For example, in why cases, so there is something which is in your hand. There is something which is not in your hand. For example, this mosquito breeding you can control. There is no problem. But you may not be able to reduce the sales of the people. So whatever is in your hand or in the people's hand, you can start implementing. But these two, why and so on, together, if you do for many diseases in a different communities, then you are going to be a best planner. And then you will come to know that if I break over here, where should I intervene? So there are various kind of intervention which can do. And evaluation of intervention will also be helpful to you, that which intervention is more useful. So cost benefit analysis also will be useful. Now, when we ask the why, that is the determinants of a disease. And for determinants of the disease, the definition of epidemiology clearly says that distribution and determinant of disease. When you use the word distribution, that is time, place, person. Time means in a particular day, which time, or in a week, or in a month, or over a period of decade. Which time, place, rural, urban, something like that, or industrial, non-industrial, which kind of country, etc. And then person, at what age, gender, etc. So, but then all those together, when you have a complete description, then you start asking why this happens. And that analysis you are going to do with the help of epiinfo software. But the basic formula which we are going to take today, because that is the basis of understanding. And in so what also, if malaria is there, you are not able to prevent the malaria, then at least start immediate treatment. And treating immediate treatment will reduce the parasite load because of the infection mosquito. So there are something you will be able to find out at which level you should start so that you can get a maximum benefit. So administration is getting things done, while management is getting things done in a most efficient manner. So the epidemiology will be helping you for the management. I hope that it makes some sense to all of you. At least one person can spell out. I need one answer from all of you, at least one answer. You can unmute. Anyone? Can anyone answer? Yes, sir. Okay. People have understood probably. So, but at least one person unmute and spell out, but or it is a stop. It is not allowed to unmute. Maybe. Okay, then you can write down the problem. Vicky, you are allowed to people to unmute?
Yes, sir, it is possible.
So, yeah, can you understand a little bit about why and so what?
Sir, I
What
think
is your-
participants can.
Huh?
This is Neeraj, sir. Who Neeraj bolu, sir? Participants can speak, spell out.
हाँ तो પછી લોકો બોલવું જોઈએ કોઈએ તો.
Yeah, somebody should speak.
Whether they are understood or not. Because these are basic. Before you start any study, you should try to find out this why and so what, and then you take up your study.
Anybody has a comment?
So Neeraj आगे चलाओ क्या?
Okay, sir.
I hope they will understand. Because now an important concept we are going to go about. Now here, what we are going to do today, that there are various kind of situation. And we are going to talk about a field where you should be applying which test, basic test. That we'll be talking today. And before that, just previously we talked about the mean and standard deviation. In that, suppose this is the one person over here. We call it as N, Y, fifth person. Suppose N1 over here, N2 over here, N3, N4, N7, and suppose N6. Now, what happens actually, that someone will be near to the mean. In this case, if you look at this N5 seems to be the near. Now, sometimes students ask you a question that we go for the formula. At that time, why we do N-1 and sometimes we don't do N-1. In this all, in case of mean, why we need to go for the standard deviation? For that purpose, we are doing the square of the differences. Why we should go for that? The reason is that these are the distances: 1, 2, 3, 4, 5, 6, 7, and 8. So look at that. There are 9 students, for example, but distances are only 8. And that's why we presume that one person will be almost near to the mean. And that's why when we talk about the distances, when this person almost near to this mean, suppose there is a mean, then this distance is too less. And that's why we are ignoring that to get the perfect mean of the divisions. Now, when these are the differences. So if we can take it as x minus x bar, x1, x2 minus x bar, x3 minus x bar. Now, when you make a total of it, what will happen that if you don't remove the minus sign, positive and negative, they will remove each other. And to avoid that, we have two options. Either you go for absolute value or make a square of it. The statistician did a lot of exercise and found out that if you make a square of it, then it is much easier to standardize, and that will give the standard reasons. And for that, they ultimately decided that let us go for the deviation square. So what standard deviation is the mean of the deviation square. It is not a mean deviation, mean of the deviation square. So we are making a summation of this. And then all the summation, what we are doing, that before do anything, instead of dividing by 9, we divided by 8 because one observation is almost near to the mean. So this is how we will get an average mean of the deviation square. This is the deviation square, mean of that. So there it will be something at this range. So because we have taken this, is you see the square will look like this. Square will look like this. Now all this square you have make a total divided by 8. So suppose mean is coming something, mean of the deviation square comes something like this. So again you need to take a root. That's why we are taking root of it. Sometimes students are asking a question, why we are taking root of n also? That is their question. And this is the reason why the whole result we should be taking as a root. So this formula, we call it as a standard deviation. So formula for standard deviation is not to be mugged up. It's basically what you are doing, you are taking mean of deviation square. Deviation means x minus x bar. How far this mean from the observation? So these words you should be very clear at any time. X is the observation, x bar is the mean. Mean means is an expected value. Whole game of statistics is what is an expected value, what is the observation. Then based on that you're talking about whether is a significant difference or not. If you understood this, it's very clear. So here the standard deviation, why we are going for standard deviation? Now we'll be going for that. Why this standard deviation we need to find out? Because if you will understand the standard deviation, then you will be able to understand about standard error. Because standard error is also one type of standard deviation. Once we know these 5 types of Z, the things becomes clear. At least manual part is over, and then we'll be going much further. So any questions so far about the standard deviation formula? So next thing is, before we go for standard error, a simple use of standard deviation. Now, when you want to understand this curve, how this curve is designed, that even you know it, you should try to do the experiment yourself. So in assignment, you should try to write down how this curve has arrived. So basically, x-axis you have some measurement variable, and y-axis you have numbers. So it looks very simple, but you should be very clear that x-axis has some measurement variable, y-axis says how many people are having this. So you can have 1-to-1 also, but because usually we have 1,000 or 500 people, we take like this columns. And when you take the columns, I will tell that sometimes it could be like this also, but usually when we have a large number of samples, we will not have that. And here, let's say we are talking about weight 51, 52, 53, 1 kg interval we have kept, young adults weight. So here is a number, let's say 5, 10, 15, 20, 25, 30, 35 like this. So when we say this area 51 to 51, 51 to 52, it will have 51, 51.2, 1.3, 51.4, 51 like this. All these people are here, total 5 people. So when we use the word, is the total area represents the number. So if you take this number, So how many people are there less than 55 kg? When we use this word, we make a total of this 25 plus 15 plus 10 plus 5 like this. And this total is under this area. This is the basis of understanding P value, Z value, etc. This column is nothing but basically a length and the width. If you make it two together, it will be something like this. So, once you have understood this, what we say that is a histogram. And when you connect point of the histogram, it will become, this is a, there will be angle. It could be like this. So frequency distribution, the word frequency, what is a frequency? Number of people between 55, 56, number between 56 to 57 kg. That is the number, that's the frequency. And frequency distribution we are showing by the histogram, but same if we join the midpoint, we call it as a frequency distribution polygon. Now, if you have not slept, it is good. Please do not sleep right now. Just we are going for a next concept. But this polygon, if it is a very closely spaced, just think over. These columns are very closely spaced, then the gone is gone. Polygon will go. And you will have a smooth curve like this. And when you have this smooth curve like this, when you have a large number of observations which you can measure, and put on y-axis the number of observation, you have a large number, the distribution what you are going to get. So, normal frequency distribution curve, because now we have converted to the normal frequency distribution curve. This is a usual, instead of normal, if you use the usual distribution curve, usual frequency distribution curve will be inverted U shape. If we use this word, we remove this normal word in from the statistics, it will become very easy for medicos to understand. Because the doctor and the medicos, for them, normal is a normal. While for statistician, normal means normally it comes like this. This word you should try to understand is the usual, it will be like this. Now, when this normal frequency distribution curve will be like this, and we have infinite numbers, what will happen? Automatically, what will happen that if we apply certain characteristics to this normal frequency distribution curve, that it is inverted U shape, bilaterally symmetrical, mean, mode, median, all coincide as 0. Then plus minus 1 standard deviations covers 68%. I am not going to go for 68.3, something like that. Please just forget that. Plus minus 2 standard deviation covers 95%. And rest 2.5, 2.5. If you understood this much, then what happens that what is a Z? We are going to try to understand this. So, this is one standard deviation away, this is 2 standard deviation away, this is 1, this is 2. Suppose in another example, this is a 60 kg, this is 70 kg, 80 kg, 50 and 40 kg. And let's say there are 1,000 people from that where we have got the data. So mean is equal to 60, standard deviation is equal to 10. So in this case, now we are going for Z. So if we say that if a person having 75 kg weight, how far is away from the mean? If this is what you are asked, so observation is 75 kg, expected is 60 kg, the difference is 75 minus 60, that is a 15 kg. But what do I do with this 15 kg? Why should I talk like this? It is 1.5 standard deviation away. Instead of that, talking about that, we are just dividing by SD. So that we are getting in terms of how many SD it is away. So standard deviation is just a parameter which is a standard and gives you a distance and it is helpful to find out a distance from observation to mean. I repeat, standard deviation is something which helps you to find out the and if anybody has seen the Z table in your any book, please say yes if you have seen Z table. Anybody? Nobody is speaking, so I should also not speak because Z table is such a simple thing which you should have seen in your book.
Yes, sir.
Yeah, so Z table is basically to find out how many people are between this 70 and 80. If you are going for the program, that all the children lying between, let's say, and on this, let me be on this side. All minors, undernourished children, you want to give a specific double thing. And the less minors, you want to give single thing. And you want to calculate, at that time, you need to calculate this area. And to calculate that area, you need to use a Z table. Right now, without Z table, we are just going to find out. Suppose this is 68%. So 34%, 34%. And this is a 95% for time being. So what this will be? 95%. And this is 68% gone. 27. 27 divided by 2. 13.5. 13.5. So if you have that table, based on probability, it will be much easier, but without that also we can find out. The 1 is equal to 100. This is the percent and this is the probability. So now when we say 13.5% of 1,000 people. So 13.5, that means 135 out of 1,000 will be between 70 to 80 kg. So based on that, you can find out how many people are in a particular group. Now we move further. Then once this Z is known, rest of the 4Z will be much easier. I ask you a question whether the person weighing weight 83 kg belongs to this group or not. Answer is very simple. Z is equal to 83 minus 60 divided by 10. So it is 23 divided by 10. It is 2.3. So here you show your concept is there. If Z is more than 2, P is less than 0.05. Why? Because Z is more than 2. It is from here more than 2 standard deviation. So probability that person belongs to the group is less than 5%. 2.5 plus 2.5 less than 5%. So we say that 5% means 0.05. 10% means 0.1. 1% means 0.01. So probability that person belonging to this group is less than 0.05. That means if there is more than 2, it is significant. Now the question is, what is the alpha error and beta error? So when you assume that the person is not belonging to the group, so although that person could be, because there are some chances. So person belongs to the group. But what you are saying that probability must less. So what you say then? do not belong to group. So what this is known as alpha error or type 1 error. What is the confidence interval? 95 confidence interval means between 40 to 80, you can confidently say that the person belongs to the group, but your confidence is 95%. Your confidence is only 95%. When you say that alpha error, that means that one error is type error, we say that it belongs to point is less than 0.05 probability that belonging to the group. Now, if you want to reduce your alpha error, you still go, instead of 2 standard deviation, if you go 3 standard deviation, then you are going to reduce your alpha error. But then what will happen? Why we don't go for 3 standard deviation, 4 standard deviation? Because there is alternative distribution also. And alternative distributions, for example, the hefty people, right? That distribution may start from this. And some of the people, although they are 77 kg weight, although they belong to the other group, you say that, no, they belong with this group. So when person is not in the group, and you say, no, he is in the group. So that is the beta. And this beta error and alpha error, both error we should try to understand. We are also going to talk about this again, sometimes repeating, so that it becomes easier to understand. So both alpha and beta errors should be considered. Now the question is, you know how to find out mean, standard deviation, etc., etc. But now, what the statistics, why we are studying this subject, we want to talk about a large population, let's say 10 lakh population. And from this, we want to find out, let's say, income of the people. Social condition, we need income of the 10 lakh population. The ideally what we should be doing, we ask each and every 10 lakh population what is the income, or let's say we have a 2 lakh families approximately, and family income we are going to ask. So it will be a cumbersome to ask 2 lakh people, more resources, etc. So we are taking a sample. So let's say we want to take a sample of 2,000 families, and we are asking them about their income. And based on the sample, we want to talk about the population. Agreed? So when you talk about the population based on a sample, you are going to make some error. And that error is known as sampling error. And now we are going for the concept of standard error. Once that concept is there, then the rest of things becomes very easy. And then the statistics, once you understand this, becomes so easy, anything you can do it. Very easy. So in this case, when you talk about the population based on a sample, you are committing some error that is known as sampling error. Now suppose this sampling error, we label it as SC. What will happen? Try to understand this. It will be more if sample size is more or less. Somebody has to give me answer. If we want to talk about population based on a sample, if sample is more, sampling error will increase or decrease?
Decrease.
It will decrease. So it is inversely proportionate to the sample size. And suppose this 2,000 people and another 2 lakh population. Here also I have taken 2,000 sample. But in this case, 2,000 sample, my mean income was, I'm talking about per day, per family, let's say it was 400 rupees. Plus standard deviation was around 80. While in this case, the mean income was 425, but standard error was 200. Just listen carefully. Here the sample size 200. Here the mean income was 400 and standard deviation was 80. Here the mean income was 425 and standard error is 200. Now here the sampling error, and here also there will be sampling error. Now this is the example A and this is example B. Even if we go on spending around half an hour for this answer, this is worth spending the answer. This is so important. Now tell me, the sampling error will be more in A or will be more in B? Based on a sample, when we talk about the population, that is known as sampling error because there will be some error. And so my question is, sampling error will be more in A, where standard deviation is 200, or in B, where standard deviation is 800. Anybody can answer?
In A,
In A, sampling error will be much more because the 2,000 people, they are up and down, so deviating so much among themselves. So when you have a sample which is deviating too much among themselves, when you talk about the population, naturally there will be more error. And so we say that standard deviation is more, then sampling, the standard error will also be more. This standard deviation is of a particular sample. So if that is more, it will be more. If this is more, it will be less. So we derive for a formula of standard error, we derive like this as d upon n. But it is inversely proportional to root n. It's not directly proportional. So when we use this word, we write like this, root n. Or it is much better to write like this. So how this formula of standard error is derived is like this. But then when we talk about population based on a sample, we can find out standard error. But how this formula was derived, for that we need to understand, spend 5 or 10 more minutes. Now, if you have understood, the rest of the things is much easier. Right. So this is a 2 lakh population, sample size 200, and in another also 2000, sample A, sample B. But now, how many such samples we can find out from the population? Just tell me the figure. How many samples possible? Anyone? 100, 200, 50, how many possible? At least one answer. So answer is not 100, but thousands of such samples you can find out because you can go for permutation combination. That's why for the whole population, let's say the population mean, we can find out by asking 2,000 families. This is hypothetical we are finding out. But on another side, let us say that from this population, we are taking a samples. Now, this is very important concept. Just now, awareness for a few minutes, we are taking sample of 2,000, or you can take 500, 300, 10,000 is possible. But for each sample, there will be a mean. X1 bar, X2 bar, X3 bar, X4 bar. These are the mean of the samples. And on this axis, I take like this 405, 406, 407. These are the means of the samples. And here the numbers of samples. Remember, this is not a number, it's the number of samples showing a particular mean. So you will have a diagram like this. You have this samples, sample means, here it is the sample means. Sample means are here. Number of samples showing a particular mean are on this side. You will get an inverted curve. Now what you have two things to do. One thing, you find out directly asking the 2 lakh families that tell me your income, or you have another alternative. Take a sample, thousands of samples, 2,000, 2,500, 2,000, 3,000, and take thousands of such samples in each family to ask a question that what is your income? Or with a database, you go on doing this and find out the samples of all this, and then mean of all these sample means, I repeat, mean of all these sample means something like over here will be almost equivalent to the population mean. So I think even though you may not unmute yourself, but just spell out once that mean of all the sample means will be almost equivalent to the population mean. Almost, right? So now I have two things. You go for the 2 lakh families, find out their income, or take thousands of samples, find out the sample mean of each sample, and then from that mean you find out the population mean. But both these two methods are so tedious that we would not go for that. So we have another method, and that method is just pay attention for a few more minutes. Say all these are, let's tell me that this is a something like x1, x2, x3, all these are the x4, x5, x. Then will be the means. And this observation, if you consider this as an observation and find out the mean of that, then what will happen? This is a, let's say, of mean of all this summation of x1 plus x2, etc., divided by number of samples. So this is almost equal to the population mean. Now, what you are finding out, you are now finding out standard deviation. So you are finding out standard deviation of all these means. Although difficult, you are finding out. Let's find out that. So population mean belongs to whatever sample mean. See, Delhi to Baroda or Baroda to Delhi, it will remain the same. So what we say that most of the people will belong to this population mean will belong to sample mean, or the mean of the means plus minus 2 standard deviation. This and this are almost equal. So now, in other way, we can say that this is a very, very important because it will be used for 4 places. That's why we are repeating this. The population mean belongs to now 95% of the means will be belonging this, and maybe 2.5% will be around this. So if you take something over here, then what will happen? That sample mean, if it is belonging to the population, it will be plus minus 2 standard deviation. Other way around, sample mean belongs to population mean plus minus 2 standard deviation. Both are same. I will repeat this formula. Now, here we are going at the end. This is a population mean that will belongs to sample mean plus minus 2 standard deviation. Or you can also write that any sample mean belongs to population mean plus minus 2 standard deviation. Both are one and the same. Now, what happens that we want to find out this? But you don't have that. You have this because one population mean you have. You don't have that full population mean. So what you are doing, that this standard deviation, to find out this standard deviation, you need to find out the means of so many samples. So what the statistician did this, they used the word standard error instead of standard deviation. So these standard errors they could find out even based on one single sample just by doing as d square upon n. This is how, instead of going for so many samples and calculating means or going directly to roulette families, what they did a miracle. What miracle? They say that for a particular sample size, this sample was, let's say, of 2,000 people, but it is a bit away from real. That standard deviation we want to find out by renaming it to standard error by this, what we learned a bit few minutes ago. Right? And now what happens that with the help of statistician, you need not do the 2 lakh family, you need not take so many samples, just go for one sample. Let's say sample 2,000 or 500, whatever it may be. Try to find out standard deviation within this, and based on, and size sample size already given, based on that, find out the standard error. Then automatically population mean you can find out by sample mean plus minus 2 standard error. That's all. So this is nothing but a concept which we are talking about. This is a standard error of mean. We are going to have total 5 types of Z. One Z we already did calculated. So now 5 types of standard deviation. I will be the 5 types of Z. I will be putting on a one graph that will tell you which formula is to be used or how it is to be interpreted in next 5 minutes. Any questions on this? If somebody asks you a question, what do you mean by standard error? You can clearly say that it is a standardized sampling error based on the standard deviation sample size. Simple. So let me clear it out. You people are not spelling out, but anyway, I hope something goes in your mind. So when you want to talk about the population based on a sample, that could be something sampling error. Now this chart is very important for all of you. This is known as diagnostic pathways for which is to be applied when. And once you have understood, there won't be any confusion anytime. So when there is some example in your case or in your study, etc., then there could be, you have 2 kinds of variable with you. Either you can find out the proportion, or you have a variable from which you can find out the mean, like hemoglobin, height, weight, etc. Sometimes even the number of persons are there. For example, you can find out the mean of the number of people, you can apply this test, there is no problem. But when you have percentage, for example, black and white, right? Or you have diabetic, non-diabetic, or hypertensive, non-hypertensive, or the joint pain or no joint pain. Like this, if you have, is the proportion. Now, sometimes you are comparing an individual. Remember this, you are comparing individual with sample or population. Individual comparison with sample or population, and you are going to use this test. There is nothing over here right now. It is in advanced statistics, but here you have mean and your standard deviation, where your Z will be X minus X bar upon SD. Here you are going to find out whether the person belongs to the group or not. And here also interpretation will be same for all the interpretation same if Z is less than 2, P is more than 0.05. If Z is more than 2, then P is less than 0.05. This will be everywhere. We are going for 5 types of Z over here. So this example we already took. Suppose mean is, let's say 10, the observation, let's say, is 15, and standard deviation is 2, that is more than 2, then P is less than 0.05. So this is a comparison when you are comparing 50 individuals. They are a group of 50 people, and one person you want to find out whether person belongs to the group or not. This is how you apply. Other way, you can say use the word X bar belongs to or X belongs to X bar plus two standard deviation, you can say that person belonging to the group. Now, when you compare the sample with population, when you're comparing sample with the population or based on sample, you are talking about the population, there is going to be some error. At that time, here in case of proportion, you apply the test of standard error of proportion. That is the PQ upon N. And here also, population proportion belongs to sample proportion plus minus 2 standard error proportion. Here also you can find out, if you want to find out the population proportion based on a sample proportion, you can add 2 SC and can find out the population proportion. While if you are comparing sample with the population, but you have only one sample to compare with the population, or based on a sample you want to talk about the population, what you are going to use is standard error of mean is equal to SD square upon N. Look at over here, SD square means SD into SD. Here we don't have SD, so we say P into Q. And its significance also we can discuss sometime. And here the population proportion belongs to sample mean plus minus 2 standard error. Here we were using the word 2 standard deviation. Here we are using the word standard error because here we are going to have a sampling error standardized. By just taking one sample, we are standardizing it and we say standard error. It is nothing but it is based on standard deviation. Now, you have 2 samples to compare. When you are comparing 2 samples, essentially you are comparing 2 populations, whether they belong to the same population or a different population. So when you are comparing 2 samples, now any example, common examples when you are taking with this, you are supposed to use it. It is very simple guideline. You are comparing 2 samples, you have proportions to compare, then you have a standard error of proportion, standard difference to proportion. You take like this. Simple. And whether this difference between 2 proportion is significant or not, that means the 2 populations from which these samples are drawn are significantly different or not between these 2. For that, you apply the simple test, the Z is equal to P1 minus P2 upon standard error. Again, if Z is more than 2, P is less than 0.05. This simple formula you can apply. But when you have 2 samples and something mean you are going to compare, let's say mean income of 2 cities, mean hemoglobin of 2 groups, like that, then you have standard error of difference between 2 means. If you look like this. And here, the difference between 2, it will equal to x1 bar minus x2 bar upon this n1 plus the standard error. X1 bar minus x2 bar upon standard. This again will tell you whether it is significant or not. So 5 types of Z. 1, 2, 3. And how do we write Z over here? Z is equal to population proportion minus sample proportion upon S. Here, Z is equal to population mean minus sample mean divided by S. So if you want to find out whether the sample belongs to this population or not, here also whether sample belongs to this population or not. So 1Z, 2Z, 3, 4, and this 5. This is 5Z by which you can usually do most of the calculation, whether it is significant or not, based of significance. So actually, this is a time whereby you should create your own examples. So I presume that at least by tomorrow, not all, at least 1 or 2% should prepare one example, another 2 example. Let's say that team number 1 and 2 will prepare these examples. Team number 3 and 4 will prepare this example. Team number 5 and 6. Team number 7 and 8. Team number 9 and 10 will make this example. Team 11 something over here. Team 12 something over here. Now, if you have 3 or more samples, what do you do? Here, I have not tried to write down over here. There is sample size less than 30, you go for the T test. Sample size more than 30, you go for the Z test. That will be discussed sometimes when we talk about the non-parametric test and parametric test. So right now, if you have 3 or more samples, here you have nothing to do except you have to go for cascade test. While here, if you have 3 or more samples to compare, you go for F test, ANOVA. So now, this is 7 things are there, but you consider 1, 2, 3, 4, 5. I said the class is almost over, and I hope you have understood what is standard error. But last but not the least, if someone give me an answer that this is all right, is a mean business okay. But when we are talking about the proportion, how this standard error come into picture? Standard is one kind of standard deviation. And we are talking about the proportion, how the proportion can have a standard deviation, standard error. So anybody can answer that question. So I hope you have taken the maybe a screenshot or whatever maybe, or I will be posting it again. So my question is, if you answer this question, it will be wonderful. Yeah. All of you may not be able to grasp this, but let me tell you how this standard comes in terms of proportion. So here we have a proportions. We have a proportions over here. From let's say 1 to 2 lakh families, what we say that the family is having electricity or not? Electricity, yes or no? And we are taking as 2,000 samples, then we can have so many proportions over here. So many samples we have taken. Say proportions sometimes 30%, 31%, 32% of a different samples proportions. And here the number of samples showing a particular proportion. So we'll have a curve like this. And in this case, we'll have a standard deviations of the proportion around the mean of the proportion. And that's why we can find out the standard error here also. And standard error with, if this PQ is larger, let's say is a 90% 10% or 80% 20%, it will be more. But if it is 50% say 50% is the highest, 2,500. But if you have, let's say P is 90% and Q is 10, it will be only 900. So we say that if P and Q are almost equal, then you will have more standard error. That's why P and Q are higher. And more the sample size, less the error. That's why it is N is over here. And this is how we got this formula, PQ upon N. Now somebody may ask me a question. If this is the case, if I have P99 and Q1, will there be much less error? No. In this case of thing, it doesn't follow the normal distribution. It follows the Poisson distribution. So Poisson distribution is a differently calculated. So when there is a rarity in a population, it doesn't follow this norms. So Poisson distribution we can talk later on sometime. But this is how we are applying standard error to the proportion also. Now the forum is now I would say open for the questions.
Not audible at what point of time? So then replacing SD with SC, we can reduce sample size. Sample size, we are reducing the, see, all depends on how much you want to have a precision. Based on that, we adjust. So sometimes when we go for the sample size calculation, at that time, we'll be talking about the precision, how much standard you want to keep, how much precision you want in your study, whether you want mean plus minus 2 standard or time. You said that you don't want to have a, let's say 400, 300 to 500. You want to have a range something like 390 to 410. You want to have a very slow range, more accuracy you want. In that case, sample size you will have more. So when calculating sample size, you need to decide how much standard you want to have. Based on that expected range, you can adjust the sample size. Any other question? Roll number 5, absent. Roll number 10. Or let me say the group 1. Anyone? Any question? Group 2. Group 3. Okay, Anuj. Somebody is, no, yes, you come out with the questions. I will be finishing in next 5 minutes or so.
So,
Please come out.
so when do you use the t test and when do you use the z test? What is the difference?
So why I not use the word t-test right now? If sample size is less than 30, it will not follow the normal distribution curve. And that's why the z-test will not be useful at that time. And that's why when you have a means to compare, you use the t.
Okay, sir. Thank you.
Any other question? This table, no, this 5Z in this tabular form will be very easy for the UG students to understand if you explain this way. So, any other question? Lesson is given to you. You need to prepare a questions, right? At least 1 or 2 questions from the each group. And also you need to look at the Z table, because if you are asked for a commissioner that how many people belong to this particular range, then you find out the Z1 for the upper range, Z2 for the lower range, find out the difference, and from one area to other area, if you remove, if you subtract, then you will get the absolute number based on the probability. If the probability is, let's say 0.1, is a 10% of the total population. So Z table is very important for the planners. So I think all of you might have used the epiinfo. If there is any difficulty, you can in the afternoon hours you can connect with our programmer. Basically, in this format, when you use the table command, it is a standard of proportion, right? And when you use the means command, it will be a standard of difference to mean. And that again, when we take epiinfo, we'll be using that trick when we using this. So, any 1 or 2 questions now? So let me quickly tell you that if you have understood more than 50%, then write down yes in chat box. If you have understood more than 50%, try to write down yes in chat box. And if you have not understood more than 50%, write no. Even 4 or 5 people, that's that sample is sufficient for me. And those who are not attending the classes, they will caught up when we ask them the questions. And without the fulfilling these questions, I will not be able to give a certificate. Okay, let me close down it. And at least I have given you a title. Write down why 3 times. If you do it 5 times, wonderful. And try to ask the so what, taking a different things. You can take a malnutrition, you can take a NCD, you can take a joint pain, etc. And I think at least one answer I should get from each 12 group. So thank you very much. I'm closing it.